Welcome to today's explainer. Okay, I want you to picture this. We are stepping right into Q Branch today because we're going to treat kitchen ventilation exactly like what it is in 2026, a high-stakes, highly classified aerospace engineering project. We're diving deep into the definitive technical buying guide to completely upgrade your culinary command center. All right, let's get into it.
But first, be honest with me. Are you still out there blindly chasing massive CFM? For decades now, the appliance industry has sold us this brute force lie that just cranking up the cubic feet per minute is the magic cure-all. Well, today, we are officially declaring that outdated, noisy obsession with raw suction power as the villain of our story. Honestly, it's the exact equivalent of trying to swat a fruit fly with a bulldozer. All you're really doing is creating ear-splitting noise, wasting an absurd amount of electricity, and completely missing the actual problem.
So here is our tactical briefing for today. First, we're busting that CFM myth. Second, we'll decode the core 2026 black tech. Third, we've got a showdown between three global engineering factions. Fourth, our expert buying guide. And finally, we'll wrap up with the ultimate insider tips, straight from the engineers themselves.
All right, Section 1, Busting Myths, Beyond CFM. Let's initiate Phase 1 and completely dismantle the biggest, and literally the loudest lie in the appliance industry.
There's a stark contrast between the old mindset and where we are today. The archaic notion is just, higher CFM equals better. But the 2026 engineering framework evaluates an extractor in a totally different way. It's all about volumetric efficiency, meaning how well does the physical shape actually capture the air? It's about acoustic stealth, keeping those zone levels, which is the unit we engineers use to measure perceived loudness, well below 1.0 at cruising speeds. And it's about AI-driven sensors that read microscopic PM2.5 particulates and thermal emissions to adjust on the fly. We are officially trading brute force for computational fluid dynamics. Moving right along to Section 2, 2026 Core Black Tech Decoded. Let's step into the armory to nerd out a bit on the core technologies, making these modern extractors absolute powerhouses. First up on the bench, we have BLDC motor architectures. So traditional AC motors, they suffer from mechanical friction. But BLDC motors use electronic commutation. Think of this as the intelligent brain of the system. When static pressure tries to choke your airflow, maybe you've got a really long duct or a strong exterior wind, this motor doesn't even sweat. It just automatically scales its RPM to overcome the friction. It is effortless, cool running power operating with surgical precision.
And how do we handle the noise from all that power? Acoustic cloaking. We aren't just stuffing cheap foam into a metal box anymore. We're talking about acoustic metamaterials and integrated Helmholtz resonators. These structures are specifically tuned to literally cancel out the low-frequency motor hum and that super annoying high-frequency hiss you get from air hitting the filters. It allows an 800-plus CFM Hurricane to operate at a total whisper, which means you can actually hear your dinner guests complimenting your cooking.
Now here's a crucial point. With modern, tightly sealed, energy-efficient homes, all this incredible suction creates a massive new problem: negative indoor pressure. If you suck 1,000 CFM out of a room, that air has to come back in from somewhere, or you risk backdrafting carbon monoxide from your fireplace right into your living room. Nobody wants carbon monoxide as an appetizer. Enter automated makeup air synchronization. It's a brilliant three-step tactical defense. The hood hits a certain threshold, sends a wireless signal over a mesh network to your HVAC, and motorized dampers automatically pop open to introduce fresh exterior air. Problem solved. But what if you live in a high-rise and you literally cannot install a duct? Well, say goodbye to those useless charcoal filters that basically just restrict airflow. The modern 2026 solution uses active canopy tech, specifically cold plasma and bipolar ionization. We are utilizing subatomic warfare right inside the hood to break down grease chains, obliterate VOCs, those are the harmful volatile organic compounds off-gassing from your searing food, and completely destroy smoke. We're talking about achieving a 98% efficacy rate compared to a fully ducted system. That's huge. Okay, Section 3, Global Three-Faction Showdown. Let's pivot to the geopolitical landscape of kitchen ventilation, because there are three very distinct global engineering factions battling for dominance here. First up, the European innovators. We're talking brands like Miele, Falmec, Elica, and Bosch. These guys are the undisputed masters of stealth and hygienic integration. Miele completely seals their motors behind these smooth, easily wipeable surfaces. Falmec somehow reduces perceived noise by a staggering 86%.
Eolica quite literally treats syringe hood as suspended structural art. They prioritize absolute aesthetics. And Bosch, they require zero user intervention, using infrared sensors to completely automate the process. Their whole philosophy is that hardware should either be completely invisible or look exactly like a high-end chandelier. Then we have the clash of the titans. On one side, the America's heavy-duty sector, your Wolf, Zephyr, and Thermador. They build brute force muscle to tame massive thermal explosions from professional gas ranges. We're talking deep 27-inch canopies and 1,500 CFM blowers mounted entirely outside the house on the roof. On the other side, the Asian high-heat specialists, brands like Fotile, Sakura, and Panasonic. They don't rely on brute force. They rely on incredibly precise fluid dynamics. They use slanted side drafts, leveraging the Kawanda effect, which is the tendency of fluid jets to attach to curved surfaces, to literally accelerate smoke before it can even expand. It's 3D vortex suction engineered specifically to intercept intense woke smoke. So it really comes down to American muscle versus Asian martial arts level precision.
Section 4. Expert Tactical Buying Guide. So how do we actually apply all of this? Let's shift to the deployment phase and bring all this professional engineering data back to your actual kitchen. We've pulled the actual engineering analysis, the fluid dynamics, and the strategic selection matrix straight from the appliance engineering division. This just proves that the strategic parameters we're talking about are grounded in authoritative, hard data, not just flashy showroom marketing fluff. So let's systematically walk through this matrix. You absolutely have to match your specific culinary loadout with the right architecture. Rocking a pro gas range? Okay, you need a deep canopy hood, 1 CFM for every 100 BTUs, and mandatory makeup air. Moving over to standard induction, you don't have that intense ambient heat, so go for a flush ceiling cassette around 400 to 600 CFM and focus purely on low zone levels. Doing high heat stir fry every night, you'll want a slanted side draft hood for that proximity capture. And if you're stuck in a ductless apartment, insist on plasma or bipolar ionization. Seriously, don't waste your time with standard charcoal. It is a rigorous but very simple mathematical exercise. Section 5. Engineers' Ultimate Insider Tips. To wrap up our briefing today, I am opening up the classified dossier on the absolute best insider tips. These are the golden rules that will save your expensive architectural builds from turning into a very noisy disaster. Let's start with the most critical piece of intelligence in this entire explainer. The ducting dictates performance. Listen, you can go out and buy a top-of-the-line 1,000 CFM blower, but if you choke it by hooking it up to a restrictive 6-inch corrugated flexible tube, it will perform worse and sound vastly louder like a failing jet engine in your kitchen than a cheap 400 CFM blower attached to an 8-inch smooth-walled rigid duct. You have to treat your ductwork like a vital artery. Next tip. Remember this phrase, capture volume over raw suction. Physics dictates that the physical shape matters way more than the motor itself. A deep canopy creates a holding volume, a literal buffer zone. So when you sear a steak and get a sudden massive plume of smoke, that canopy catches it, giving the blower time to extract it. Those super sleek, flat, purely aesthetic glass hoods, they offer absolutely zero capture volume. The smoke just hits the flat glass and instantly spills right back into your living room, no matter how high the CFM is. At the end of the day, physics does not care about your aesthetic dreams. And finally, our magic number for today is 6. Thermal plumes always expand as they rise. The higher you mount your hood above the cooking surface, the wider it needs to be to catch that expanding V shape of smoke. If you mount your hood at 36 inches high, it must be an absolute minimum of 6 inches wider than your cooktop. Otherwise, you are literally just greasing your ceiling. So take a look around your kitchen. Your appliances are getting smarter, your home's insulation envelope is getting tighter, and honestly, your cooking is probably getting more adventurous. But is your ventilation keeping up, or is it stuck in the past? It might just be time to upgrade your tactical layout, finally discard that old CFM myth, and let fluid dynamics clear the air. Thanks for hanging out with me on this explainer today, and as always, stay curious.